And today we're going to look at the section 6.6, graphing linear equations. So what you will learn in this section includes we will introduce Cartesian coordinate system, and then we will graph linear equations by several methods, either by plotting points, by using the x and y intercepts, or we will also study the concept of the slope of a line, and we were also using the slope and the y-intercept form to graph linear equations. It'll become clear what those terminologies mean. All right, Cartesian coordinate system. This should not be uh, strange to you. So you have a horizontal line, typically called the x-axis, and also you have a vertical line, um, and typically denoted by y, and that's your y-axis. And then the intersection of x-axis and y-axis is called the origin. And then we can talk about the coordinate of a point in the xy plane. So each point in the xy plane corresponds to a unique ordered pair A and B. Ordered pair meaning that the order, when you change the order, then you change to a different point. Okay, so the first number represents the x coordinate, second number represents the y coordinate. Okay, so example 5, plot the point 5 comma 3, meaning the x coordinate equals to 5 and the y coordinate equals to 3. So what you do is you always, you can describe this, always start from the origin here. Now, because the x coordinate is 5, is positive 5, so you move or go toward the right, toward the positive direction by 5 along the x-axis, right? And then because then you move along the y direction now, because the y coordinate is 3, so you move up, move toward the positive direction of y. So you move up 3 units, you end up with that. So that's how you find the point with coordinate 5 comma 3. Okay. Now let's look at this example here to test our understanding of coordinates or plot points in the xy plane. So let's say we are given 3 points with coordinates shown here, and they are the 3 vertices of a parallelogram. Okay, so and also we know that the 2 sides of the parallelogram parallel to the x-axis. So we want to plot this parallelogram, and notice the fourth point, fourth vertex D is unknown. Okay, unknown and need to find. We need to find. Okay, so let's see how we solve this problem. First, we notice a parallelogram from elementary mathematics. We know that it's a figure that has opposite sides that are of equal length and are parallel. Okay, so opposite sides have equal length and also are parallel. Let's see. So we are given A, B, C. So let's first identify A with coordinate 1, 2 is here, and B with coordinate 2, 4 is here, and C with coordinate 7, 4 is there. Okay, so let me give you some idea here. So let's see, we got A, we got B, and we got C. Okay, A, B, C. So notice the y coordinate of B and C, they are equal. So that gives you a horizontal line BC. Okay. Um, so now because we know the ABC are three vertices of a parallelogram, so um, we need to decide where the fourth vertex is, where D is, right? So obviously here, notice that because we already know that those are fixed. We already know that. A, B, and B, C, because they are determined by the vertices A, B, and C. So we also know that parallelogram. So we don't know where the vertex D is, but we know that the opposite sides have to be parallel. Therefore, because we know BC and the opposite side through vertex A must be on this line, right? So therefore, the fourth vertex D could be either um, to the left of A, could be here, or to the right of A, so it could be here, or actually D could be also here on this side, right? On this side. That's why there are two solutions, okay? Now, if D is to the right of A, then obviously this you are looking at um, this parallelogram here. Okay. Now, what if D is to the left of A? Then you are looking at this. So, because C is fixed, A, B, C are fixed, right? So, and DA has to be parallel to BC. So you are looking at, in this case, would be that. So that's another solution. So in this case, we can, if we mark this as D prime, um, then you have one solution is A, B, C, D. Another solution is A, actually A, D prime, B, C. That's what we draw here. The first solution is this here, and the next solution would be this here. That's how you get the two solutions. Okay. All right. Next, we're going to talk about the graph of an equation, and also, in particular, we're going to look at the so-called linear equation of two variables. Okay. Again, if you recall, linear meaning that the coefficient, the exponent of the variable is 1. Okay. So you only see x and y. Two variables, of course. We have two variables, x and y. Now, graph just um, the collection of all points whose coordinates satisfy an equation. Okay, so in particular for this linear equation ax plus by equal to c, where a and b are not equal to 0, then its graph is always a straight line. Okay, it'll become very clear later. Example here, 3x plus 2y, let's say equals to 1. The graph of this linear equation is a straight line. Okay, so this is very basic concepts. You need to basically know this. Okay, um, So, how do you plot or find the graph of a uh, linear equation? So what you can do is because we know the graph is a straight line. So and a straight line determined by 2 points. So what you can do is to find 2 points, and then you can draw a line through the 2 points. That's the graph of the equation. Okay. Now, a lot of time in practice, we also find a third point just for checking, the other 2 points are found correctly. Okay. Not all those 3 points, because they should be in the same line, so they are said to be collinear on the same line. Okay. Uh, so here are some specific examples or specific steps you can take. And typically, for convenience, you want to solve the equation for y. Now, once you have the equation for y, all you need is take arbitrarily 3 values of x, okay? And then you find their corresponding y values, and then you plot 3 points, and then connect the 3 points with a line that would be the graph of a linear equation. Okay, example here, y equal to 2x plus 2. So here we don't need to solve it for y because it's already given to us. Otherwise, you need to solve it for y first. Okay, so you first get it somehow get the expression y equal to some x plus some number 2x plus 2, and then you just arbitrarily choose 3 values of x. Example, you choose x equal to, let's say, x equals 0, and you find y value here. You plug in x equals 0 into this equation here, so you get y equals to 2x plus 2, right? Now, 2 times x plus 2, that's 2. Right, so that's why you get that. Let's check another. What if x equal to 1? Well, 2 times 1 plus 2. 2 times 1 is 2, plus 2 is 4. So that's why you get 4. So similarly, you can get this. Okay, when x equal to -1, y equal to 0. And then you plot those 3 points and use a line, connect those 3 points. Then you get the graph of the line. Okay, so x-intercepts, y-intercepts. So what are those things? Okay, so typically, if you have a line in the xy graph in the xy plane, it will look like something like this. Okay, example here, and the x-intercept in this course is defined as this point. It's this point where the line crosses x-axis. So that's the x-intercept. And y-intercept, that's where the line crosses the y-axis. Okay? So notice that the x-intercept, its x its y coordinate is 0. So it has to be some number, and we can use a, for example, a represent, and its y has to be, let's say here is a, has to be 0. Okay. For the y-intercept, because it's on the y-axis, its x coordinate has to be 0. So typically we use b to represent the y-intercept. So those are very special points because one x-intercept is on the x-axis, so its y coordinate is 0, right? So that actually gives us a way to find where the x-intercept is, where the y-intercept is. So this is to find the x-intercept, you set y equals 0 because its y coordinate is 0. To find the y-intercept, you set x equals 0. Okay. Let's see. Let's look at this example here. So we want to graph this equation, linear equation, by using the x and y intercept. Of course, that means that we need to find the x and y intercepts, and then once we find the x and y intercepts, we find 2 points. We just connect those 2 points. Okay. So here, let's see how we solve it. First, we find x intercept. Okay. Or to find x-intercept, we set y equal to 0. Okay, set y equal to 0 in the equation, of course. So I have 2x plus 3 times 0 equals to 6. Okay, because that's y. That y equals 0. So solve this for x. So this gives you 2x. 3 times 0 is 0 equals to 6. So x equal to 3. Okay. So this means that x-intercept can be represented by the point 3, 0. Notice it's y equal to 0, x equal to 3. So we can go ahead and plot the points over here in the xy plane. Okay. So let's find the x-intercept. It's a 3, 0. So 1, 2, 3. Right. So let me use a color. So this is the point 3, 0. Okay. Let me change back to blue. Now let's find the second step. Find y-intercept. Okay. In this case, you're going to set, because it's a point on the y-axis, you're going to set x equals 0. Okay. So now you're plugging x equals 0 into the equation. You have 2 times 0 plus 3y equals to 6. And obviously 3y equal to 6 and y equals to 2. So y equal to 2, x equal to 0. So y-intercept, it's the point x equals 0, y equal to 2. Now let's find this, okay? So we look for this point on the y-axis. So it's because it's y. So y equal to 2. That's 2. So we can plot this point. And then we just need to connect these 2 points to get to the line. So this is the line describing the equation 2x plus 3y equals to 6. So that's how you solve this type of problem. Okay. So here, just the solution given by the book. Now, next, we need to talk about an important concept for a straight line called slope. Okay. So slope of line is just the ratio of the vertical change to the horizontal change. Okay, for any 2 points on the line. It describes the steepness of a line. So let's take a look at this. So its formula to calculate the slope of line is vertical change divided by horizontal change. Typically, we use m to represent a slope. So y equal to uh, this formula here. So let's see, we have a line, x coordinate, y coordinate. Let's see, we got 1 point here, 1 point here. And this point has coordinate x1, y1, and this point has coordinate x2, y2. To find the slope, what you do is you find the change in y and change in x, and then you do this. So m equal to the change in y is y2 minus y1. The change in x is x2 minus x1, and you take the ratio. Okay, so sometimes we use delta y to denote y2 minus y1, and delta x to denote x2 minus x1. So here, that's delta y, and this is delta x. Okay, so this is x1, this is x2, here is y1, and here is y2. Okay. Positive slope. Positive slope, you always have a line look like pointing forward, pointing to the northwest direction. Okay, northeast actually. So let me change it. Northeast direction. Okay. Now, why when you have a positive slope, the line points to pointing forward or pointing to the northeast direction? Well, if you think about a slope is defined as delta y over delta x, right? So m equal to delta y over delta x. So a positive slope basically means that when you have a positive change in x, then your y should have a positive change. So this is sometimes read as rise in y over run in x. So positive slope means that you have a positive run, and then you should have a positive rise. Okay, so that's why. Now negative slope, similarly, in this case, notice that this is your delta y, this is your delta x, right? So in this case, if you run towards the left, you rise above. So m equal to delta y over delta x. In this case, the delta x is negative, and delta y is positive. That's why you have a slope less than 0. And in this case, the line pointing toward the northwest direction. Northwest direction. Now, what about a horizontal line? Or a horizontal line looks like this in the plane, and let's assume it has a slope, has a y-intercept b. So here, that distance is b, right? And then the equation for it is just y equals to b. Fairly straightforward because look at every point on the horizontal line, they all have y coordinates equal to b. Okay. What about a vertical line? A vertical line looks like this, of course. Let's assuming that here this distance is a. Okay, so in this case, the equation for this line would be x equals to a. Again, if you look at any point on the line, they will have the x coordinate equals to a. Example here, let's see if we look at this line and assuming this distance is -2, then the equation for this line would be x equal to -2. Okay. All right, so let's find the slope of a given line, but going through 2 points. Well, you can plot the 2 points and plot the line, and that is fine. But you can directly calculate slope equals to y2 minus y1 divided by x2 minus x1. Okay, so here we need to make sure that which is which is y2, which is y1, and so on. So let's see, we denote p1 for this point, and we're gonna call it the first point. It doesn't matter you name which point as the first point. Okay, we denote the point with coordinates 1, 5 as the second point, p2. So for p1, we're gonna associate x1 to its x coordinate and y1 to its y coordinate, and this is x2, this is y2. So that's what we mean here. Okay, so x2, y2 come from the same point. x1, y1 come from the same point. So the p2, they come from p2 and they come from p1. Okay, so make sure you do not want to mix them. Okay, so you just plug in numbers. Y2 is 5 minus y1 is -3. So make sure you have the sign correct. Okay, and x2 is 1 and x1 is -1. So 5 minus 3 is 5 plus 3. 1 minus 1 is 1 plus 1. We have 8 over 2. We have 4. So the slope of this line is actually 4. Okay, that has to be positive because if you plot the 2 points here, plot the 2 points, gonna look like this. 1 point, -1, -3. The other point is 1, 5. When you connect the 2 points, they're pointing to north, eastern direction, pointing forward. So the slope has to be positive. Slope x4 is positive. Okay. Now we can interpret the slope as rise over run. Okay. So 4, m equal to 4 equal to rise over run. Okay, rise of course in y and run in x. Okay, so 4, when we talk about rise over run, so we need to interpret the slope as a ratio. Now 4 always can be written as 4 over 1. So that means that when x runs +1, y runs +4. So you can do when y rise +4, then x runs +1. So if you go here, let's say you fix this point, you go up by 4, rise by 4 in y, 1, 2, 3, 4, then you run in x by +1, you should get to the point on the number 9. Okay, so notice this is also 4 is the same as -4 over -1. So that's why if you run by -1 from here to here, you need to rise by -4, which means going down 1, 2, 3, 4. That's why you get this point. Okay, so that also explains the meaning of slope. Slope-intercept form for an equation of a line. Okay, so the slope-intercept form of an equation of a line is equal to this form: y equal to mx plus b. B, that's the y-intercept. Okay. And m, that's the slope. Okay. So let's look at this. How we can graph a linear equation using the slope y-intercept form? Well, you first need to find the slope y-intercept form, right? So in that, to find the slope intercept form, you need to solve for y. Okay, and then you determine slope and determine y-intercept, and then you can find 2 points. Then you can plot the line because that's the step. Okay, so let's see. We want to first write this. We got a linear equation in 2 variables, and we want to graph the equation. Now, to use slope-intercept form to graph the equation, we can do the following. First, find the slope-intercept form, and then we graph, right? So let's solve for question A. We want to find the slope-intercept form. So we are given this equation here. What we need is we need to solve this equation for y, because our goal is to get y equal to mx plus b. Okay, so we want to get y equal to something. So we need to solve that for y. Well, remember, to solve for y, we need to isolate that term on the left-hand side. Okay, that means that we need to move 4x to the other side. So I'm gonna write a little bit of detail here. So minus 4x from both sides. And then I have 4x minus 4x that cancel out. So I have negative 3y equals to 9 minus 4x. And then I need to divide both sides by negative 3, right? So negative 3, or divide every term by negative 3. Okay, so I get, this gives me y equal to negative 4 thirds. I just write the term of x first, and then minus 3. Okay, so this tells me, so remember this matches mx plus b. So this means that m equals to negative 4 thirds, and the y-intercept b equals to negative 3. Okay, so negative 4 over 3, you can always interpret that as rise over 1. Okay, that will help you to find the other point. Okay, that's plotting x, y. Well, first we need to find the y-intercept. So b equal to negative 3. So 1, 2, 3. So here, that's the y-intercept point. Okay. Next, we're going to use the slope, negative 4 thirds, to determine another point. Well, the slope of negative 4 thirds, meaning that if I run positive 3, I'm going to rise negative 4. Or if I run negative 3, I'm going to rise positive 4. Okay, so let me let me do this. So 4, negative 3. So if I Wrong by -3, meaning that they go left by 3 units. So 1, 2, 3, right? And then I rise by +4. So 1, 2, 3, 4. So that would be my the other point, the second point. So I can connect those 2 points to get to the line. 4x minus 3y equals to 9. So that's how you solve this problem. So here, it's a solution given by the book. Okay, y equal to -4 third x minus 3. Y equals to minus x. Okay. Now, what about this? We want to determine the equation of the line. We are given the graph of the equation. Well, notice that we can identify from the graph the x-intercept or x-intercept point is this point, right? That's actually an x-intercept point. So it has coordinate 3, 0. And also we identify the y-intercepts. That's your y-intercept. Has coordinates, obviously you can read it, the y-intercept point as 0x coordinate and 1 y coordinate. So notice 1, that's your v, right? So we need to find the equation, we need to find m. And notice in this case, the m has to be less than 0 because the line pointing toward the north west direction. So now notice that if we run by -3, so m equal to rise over 1. Now if we run by -3, so we go in left from this point, we rise by 1, up by +1. So this tells me the slope equal to -1/3. Now the equation using the slope-intercept form y equal to mx plus b equals to -1/3 x plus 1. So that's the equation, right? We solve the problem. What about graph y equal to 2? It's a horizontal line because this equation means every y coordinate is 2. Well, this has to be a horizontal line, right? Now, what about x equal to -3? Well, this is a vertical line because, again, x equal to -3 means that for any point, its x coordinate is -3. So you get a vertical line with x-intercept equals to -3. Now, we often hear the name dependent variable and the independent variable. It just means this. So suppose you have y equal to, let's say we talk about ax plus b or mx plus b. Okay. So notice the y value depends on the value of x. So x is referred to as independent variable, and y depends on x, so it's called dependent variable. So those are just terminologies.